So today we're going to talk about permutations and combinations. These are used to determine the number of ways an event can occur. And the main difference between, or the only difference between the two is in a permutation, the order matters. So in a permutation, right on it, the order is important. Like if you have a race, who's in first place, second, third place, the order matters. A combination is just a group and the order does not matter. So that is the difference. Okay, so for our first example, let's say a company has a 5-digit code that each employee has to use. How many codes could they create if they reuse the digits? All right, whenever we're talking about digits, we're talking about numbers. And if they don't specify, we're going to assume 0 is a digit, 0, 1, 2, all the way up to 9. So the digits we can use are 0 to 9, which is there's 10 digits. So when you pick your first number for the code, there's 10 different digits they can pick. And there's actually 5 spots. There's the first spot, second, third, fourth, and fifth. And they get another digit for the next spot. How many can they choose now? Well, if they can reuse the digits, they still have all 10 they can pick. And in the third spot, they have all 10. And in the fourth spot, all 10. And the fifth spot, all 10. So maybe their code is 77777. That would be okay because they can reuse them. So when you multiply this all together, you get 10 to the fifth power. And that's a 1 with 5 zeros. 1, 2, 3, 4, 5. Bring our commas every 3 coming in. So it's 100,000 different codes that company could have if they repeat the digits. What about if they cannot reuse the digits? This is what's called a permutation. If you're ordering them, once you use it, it's done. So we still have our 5 spots. We would still have 10 choices for the first one. So let's say the number 4 was used in the first one. They can't have that again in their code. So once the number is used, how many are left for the second spot? Well, then it goes down to 9. So maybe they use the number 0. So now 4 and 0 are out. Then how many are left for the next spot? 10, 9, and we go 8. And we use one up, 7, and 6. Okay, you can multiply all that out and you get 30,240. You can also do the permutation button, which the Delta Math program does have it on there. So it looks like it's going to be a permutation. We've got 10 total digits, and we're going to pick 5 of them to put in order. And I want to show you how to type that in, and it should give us the same answer. So a permutation of 10 choose 5. So let's go to Delta Math. Okay, so there's a calculator up here that you can click on. And right here, you can go to the functions button. This is combination, this one's permutation. So we're doing a permutation. And I think so there was 10 digits. We're going to pick 5. So I'm going to type in 10, and then go past the comma, choose 5, and enter. And it says 30,240, and that is what we have. So that's how you type it in with your Delta Math program. And there's the same answer. All right. So on these ones, this is how you write permutation, and the C one is the combination. So let's make a story to go with each one. Permutation, the order matters. This is how many total we have. There's 25, let's say, students in a class. And this is how many we're going to pick, but the order matters on a permutation. So we've got 25 students. Let's say that I'm going to pick 3 students to come up and do some problems at the board. There's 3 different problems at the board. I'm going to pick the first student's going to come up, a different student's going to come up for the second one, and another student for the third problem. If we type it in, just like we learned before, it's going to give you 13,800 different ways that I could pick 3 students out of class of 25 to come up and do different problems on the board. The second one, the combination of 25 to choose 3, there's still a total of 25 students. Now I'm going to pick 3, but the order does not matter. We're just going as groups. So I'm going to pick 3 of them to be on the recycling team, and they're going to take the recycling out. And so I'm going to go to this, and the difference is I'm going to pick the combination button. And it was 25, so I'm going to type in 25. I'm going to arrow over, and I'm going to pick 3 of them to be on the recycle team. The order doesn't matter, so it's a combination. So it's the same, I just picked the C button. And that says 2,300. So it tells us 2,300. And that is me. Combinations, the amount should be lower because you're taking away the order. Adding the order means you can arrange them different ways and it gives you more choices. So, all right. Here's an example 2. 10 students are in a competition. First place wins $100, second wins $50, and third is $25. How many ways can the awards be given out? So this is an example. Everything is permutation or combination. The right answer is permutation because the order matters. So it's a permutation of, there are 10 students. That's the total we're starting. There's 10 students. How many are we putting in order? Well, there's first, second, and third place. We're picking 3 put in order. We're getting the top 3. When you type that in, you get 720 ways that this could happen. If you're using your own calculator, you may enter it differently. You might have to enter the number 10 first. Then you go like a probability button, find this permutation button. You type that in, and then you type the 3 in after. Okay, but you can just use a calculator and Delta Math too. And all right. Here we got 10 students in a competition. The top 3 will get $50. So they're all getting the same amount. So it's not like the order matters. The top 3 group is going to get $50. So how many ways could they give out the money? So this is an example of a combination. The order doesn't matter because they're grouping the top 3 as a group. They're all getting the same amount of money. So when the order doesn't matter, it's a combination of, there's 10. We're going to put 3 to put in order. And when you type that in, you get 120 different ways that they could pick the top 3 that are going to get the $50. All right, a few more slides. Example 4, Hot Pants Pizza has a special where you can get a 4-topping large pizza for $12.99. They've got 13 toppings to choose from. How many different ways could you choose the 4 toppings? Okay, this is an example of everything what you think it is? Combination. Why? Because the order doesn't matter. Unless you're super picky and you say, I want pepperoni on the first layer, ham on the second, like that, you just tell them the 4 toppings. So the order does not matter. So we're going to do a combination. How many total toppings are there? Let's look. 13. How many am I getting to pick from the 13? I'm picking 4. The price was just extra information. We didn't need that. Sometimes there's extra information we don't need. So I want a combination of 13, choose 4. I would type that in. I get 715. That's how many different pizza specials they could advertise that they have. 715 different ways you can make this 4-topping pizza. All right, so when the order matters, it is, what do you think? Order matters, it's permutation. When the order does not matter, it is combination. And you can use the buttons, the C for combination, P for permutation. I hope this helps and have a great day.